system on the generator, and so I started to talk about that. I ordered some 0.1mm thick by 100mm wide steel, ferric steel, that is, not stainless, but it's ferric sheet. And the idea is that I'm going to wrap some foil around these coils to rotate the field as the rotor's spinning and the anti-drag. Now the idea is that, as I've been demonstrating using magnets against the rotor, the magnets have a wider footprint, so they work better when they're actually skimming over the rotor to create the anti-drag system. Now, because these coils are individually wound, we've got multiple spins, flux spins around all these wires, and that is causing some problems with the anti-drag circuit. So, having done a lot of thinking about this, it makes sense that if I wrap some very thin steel foil around the coil, it will pivot the field, and it will also even out the irregular spins that we get from each piece of wire, each copper wire, so that it'll be more even. And basically it's like shifting the focus. It's like attenuating the footprint so that it's a wider footprint instead of being lots of little tiny pinpoints, pinpricks of fields. So it should work much more efficiently. The only catch with that is it will induce more drag because it's steel. It will induce a certain amount of drag on the system, but that's why I'm going with very thin 0.1mm thick foil. It's very thin. So I have been experimenting with the nanocrystalline on the back of these other coils, and I know I talked previously about using capacitors, but I'm not going to do the capacitor idea yet, because that means winding a whole bunch of more of these coils. And I just thought I will try this other idea first, because it means I can use the existing coils. So the idea is I'll break the pegs off one end of the canopy, just to release the wire, because it's hooked around there and I can't get it off, obviously. So I'll just break these pegs. I can stick them back together with acetone or glue or something, so I can get the wire to fall back. Then I can wrap the foil around the wire on both these. I'm going to do it with this one as a test to see what difference it makes. Instead of doing it on all of these, I'll just do it on this one as a test, because this coil here has got the lowest output. It's basically 2.24 volts RMS, 7.92 volts peak to peak. So it will give me a bit of an idea as to whether or not that idea is going to work or not. So instead of doing it on all of them, I can just do it on this one to test out. So I've ordered some foil. It's coming from you know where. So it's going to be several weeks before it arrives. They said 15th of May, I don't know. No, 15th of June, I think they said, but it's probably going to get here a bit quicker than that. I've been doing tests at the moment. It's the LEDs at the moment are drawing 25 milliamps. They're actually drawing quite a bit of current at the moment, and I'm only running at about 1145 RPM right now. So I just wanted to give you a heads up on that. The other idea was I made these things, these little, I populated a few pieces of steel into this, and these things go in, well, I can't put them in right now because I've got these things on the back of the coil, those coils, but basically the idea was that I put them into the bobbins to bend the flux around the back of the bobbins like this. And I tried this out, and to be honest, it was a waste of time, but it was worth trying out anyway. It was an experiment. That was the other idea. That was the other idea I had, and it didn't really work out. because there was a bit too much drag from all this iron. That's why I'm going with the foil idea instead. So in the meantime, instead of using the capacitors for now, still got a bit more of this rod stuff. I've got plenty of that actually. So the welding rod stuff. So I made a couple of these. I've got another one in the vise at the moment. It's in the other room. I've been squashing it because it got a bit warped. So anyway, I tried that. I inserted this into the back of these coils over here to try to bend the flux lines around as it was leaving, to see if we could offset the drag. And it did increase the output, but it didn't really offset the drag sufficiently. So that's why I've decided to go with the foil idea, because it's basically using like a toroidal effect. It's like when you wrap a piece of foil around the coil, it creates a toroid effectively around the coil. So as you know, the magnetic field will pivot around the toroidal. We still have attraction and repulsion, obviously, and that is part of the reason for the drag. But I'm hoping that by using the toroidal effect, it will spread out that magnetic field from the individual wires into a more linear effect against the rotor, so that it will do more accurately what happens when I use a static magnet against it. You know, it's got a wider footprint. So anyway, that's what I'm working on right now. So I'm just waiting for that to arrive, that foil to arrive in the post, and I ordered it to specification, so it's actually the full width of the canopy. It's 100mm wide, which is what this is, 100mm from that end to this end, because there's 3 rotors. And it's about, I don't know, I think it was about 1 meter long or something. There's more than enough there. So the other idea was to make some tubular foil mini toroids, and pack some of those above the coil at the top, so that there's I'll wrap it around a former, like a piece of plastic, like a piece of rod or something, or a pencil, something thin, like I talk about 2mm thick piece of plastic insulator. Wrap some pieces of foil around that to put it on the entry point to the coil, and also on the exit point to the coil, and also wrap the coil inside a tubular piece of foil. So that's what the next plan is, and that should help to reduce. It'd be like rolling. It's like rolling the flux around rollers, basically. And it's, you know, a roller effect. You know, when you skateboard or something. You know what I mean? It's kind of, yeah, you get the idea. But anyway, we'll see how that works when I get. I just want to show you the waveform at the moment, because the LEDs at the moment are 25 milliamp or something. I'll turn the light out so you can see how bright they are. They're pretty bright. You see it lit up pretty well there. And the oscilloscope readings at the moment. About 57 hertz. Peak to peak 22.5 volts, 7.44 volts RMS, cyclic RMS. So the waveform's not bad, it's pretty good. So yeah, that's all really for now. I'll keep you updated. So right.